Hello students, here we have some numericals on bandwidth. So let us go for it. The very first question, students, what it is telling you that monochromatic light from a narrow slit illuminates two narrow slits and they are kept 0.3 mm apart and they are producing an interference pattern with bright fringes 1.5 mm apart on a screen 75 centimeter away. Now, you just need to find out the wavelength of light, the first task. The second, how will the fringe width be altered if, two cases for it, the distance of the screen is doubled and the separation between the slits is doubled. So this is what is there. We have to find out three things here, and what is given, let us just note it down. The very first part, two narrow slits, 0.3 mm apart, that is nothing but small d, right? Small d is equal to 0.3 mm. And after that, we would also say that 1 mm is nothing but 10 to the power minus 3 meter. So we would convert it into SI unit, and I can write it like 3 into 10 raised to the power minus 4 meter. And students, you can also write down that distance of bright fringe is given, right? So this is nothing but capital X, and this capital X is 1.5 mm. Again, I can convert it into 1.5 into 10 raised to minus 3 meter. And the distance of screen, that is capital D. Capital D is 75 centimeter, and centimeter could be written as 0.75 meters. So this is what is D is. And students, this is what all was given. We just need to find out three things. The very first one here is lambda, that is wavelength of the light. The second one is distance of the screen is doubled. The case you need to find out fringe width, that is X. What would be X if the distance of the screen is doubled? That is X nu in case that capital D is doubled. The third, the separation between the slits is doubled. That is X nu when small d is doubled. So these are my two we found out things. Let us calculate it one by one. The first one is what? Lambda, and we would be basically following the same formula for it. X equals to lambda d by d. So this is what is fringe width stands for. And I would say that given is here. So wavelength of light, that is lambda, would be x d by d. We have all these things, right? We can say that x is already 1.5 into 10 raised to minus 3 meter, and small d is 3 into 10 raised to minus 4 meters, and capital D is nothing but 0.75. So by substituting all these values here, I'm going to get what is lambda, and lambda is nothing but 6000 angstrom unit. So guys, this is what we have calculated. Lambda, first of all, this is not end of numerical. We have just calculated first part of it. The second part of it is fringe widths. It's that the first case of fringe width was capital D is doubled. The formula is going to remain same, right? It's going to be x equals to lambda d by d, but the x nu would be lambda d nu by d, right? So let us try to divide it, and on dividing, what is going to be the answer? We would be just keeping it in ratios. Similar terms would be getting cancelled here, and the leftover is nothing but looking like d nu upon d. We know that this d nu is nothing but twice of d. Substitute it. X nu upon x is 2d upon d. On cancellation of d, we're going to get x nu as nothing but twice of x. Now, is x known to us? Yes. What it is? X is nothing but 1.5 into 10 raised to minus 3 meter. Substitute it here. You would be getting what is x nu, right? So this is value of nu x when your particular distance of screen is doubled. So I can say x nu is nothing but 3 mm. The third part of it. What was the third part about? We have already means we have doubled the distance of width. So I can say that x is calculated by x equals to lambda d by d, and the x nu is nothing but lambda d by small d, but that new one, so I would write it like d nu, and I would be following the same strategy. I would be taking it into ratios. I would be cancelling out the similar terms here, and I would be writing what is left here. So what is my observation? That x nu by x is nothing but small d by d nu. So students, we are finding for x nu, right? So x nu is nothing but by substituting small d and d nu. D nu is double of the initial d. So I can say that d upon 2d would be d gets cancelled out and you would be just left with 1 by 2. So the x nu is nothing but half of the previous one, that is it would be x by 2, and the x value is the same, right? 1.5 into 10 raised to minus 3 meter. So just by substituting that, we are going to get the value of x nu as 0.75 into 10 raised to minus 3 meter, and this x nu would be nothing but equals to 0.75 mm. So that was from this module, students. Thank you.